Hi, in this video I'm gonna cover the last section of the vector chapter. It is called the vector equation of a line. Okay, this section is probably the most challenging part of the chapter. Okay, so before we do that, I want to go over a very similar concept which we learned back in Algebra 1. It is called the equation of a straight line in point-slope form. Okay, equation of a straight line in point-slope form. So that equation says that I can figure out the equation of a straight line by this formula. Y minus y1 is equal to m multiplied by x minus x1. Okay, where my x1 and y1, they are just any point on the line, and my m is my slope of the line. Okay, so let's try an example for that. So here I have a straight line, and let's say I want to find the equation of this line. Okay, so let's try to find the slope first. I have a y-intercept there and another x-intercept there. So what's my slope? So rise over run. I hope you guys still remember this. I'm going from, and then I'm always going from left to right. So I'm gonna go 3 units to the right. My rise will be -3. I'm going down. My rise is -3. My run is equal to 3. So my slope is -1. Okay. Now I already have a point on this straight line, which is 1, 2. So my x1, y1, my xy, y1 in this case is 1, 2. And with my slope and a point on the line, I can write the equation. So y minus my y1 is 2 is equal to my slope is -1 multiplied by x minus my x1 is 1. So I can simplify that as negative of x minus 1. And I can leave it there like that. Okay? So this is the point-slope form of a linear equation. And the concept behind the point-slope form is very similar to the concept that we are going to talk about now to find the vector equation of a line. All right? So in the previous videos, I mentioned slope a couple of times, and for lines that have the same slope, so for example, this is my slope 1, this is my slope 2. If my slope 1 is equal to my slope 2, then that means the two lines are parallel, right? Now, in terms of a vector, if two vectors are parallel, so this is my vector A, this is my vector B, and vector A is parallel to vector B if I can write them like this, right? With a k value in the front. K can be any positive or negative real numbers, right? All right, now we are going to use pretty much the same concept so to figure out the vector equation of a line. So this is it. Now the vector equation of a line is simply so normally we use R. We use R to represent the vector equation. The vector equation of a line is equal to vector A plus a value of t, multiplied by a vector B. Okay, so this represents the vector equation. This is the vector equation of the line, Now, and t is just similar to k. It's just a scalar value. It's just some scalar, right? It's just some value, okay? Can be positive, can be negative. Now, let me use different color. A and my B, I need to be careful with that. My A is the position vector, the position vector to a point on the line, the position vector of a point on the line. Okay, so it's very similar to this 1/2 here, right? Very similar to that. And what's my B? My vector B is just a vector that is parallel to the line. Okay, my vector B is just another vector that is parallel to the line. So that vector B is sort of similar to my slope over there. All right. Please feel free to rewind this part. Please feel free to rewind this section of the breakdown of my vector equation. Okay. Before you continue on with this video. So we call this. Some people might call this the same thing differently. Some people will call this vector B. They call it the direction vector. The direction vector. So you guys might hear me saying that sometimes. But for this vector A, the position vector of a point on the line, that's pretty much a common language. But this vector B, some people will say that's a vector parallel to the line, or some people will call that the direction vector. Okay? All right, now let's look at an example then. All right, so here I have an example. I want you guys to pause the video and go over the question. Okay, welcome back. Now, all we have to do is to find the vector equation, or that means my vector R, right? Normally we use the R to represent vector equation. And we need to find the vector equation of the line through this point. So, which means this would be my A, right? That would be my A. And the line is parallel to the vector of this. So this part would be my B. Okay? So my vector equation would be R is equal to, so just let me put down the general form. This is some T multiplied by vector B. So this vector A in this case, so this point is a point on the line. So what's the position vector of that? The position vector of that point would be 1, -1, 3. Right? That's just the position vector. Remember that position vector is just a vector coming from the origin to the point, right? So the position vector of this point is 1, -1, 3. Plus T is just some random value, can be any value. And now a vector that is parallel to the line. In this case, I will have -1, 3, and -1. And that's it. Okay, that's it. I'm done with this. Now, you might have noticed that for my I, J, and K, I give them that small cap on the top to represent that they are unit vectors of my X, Y, and Z axis. Okay, so I think it's a good habit for you guys to do that too. Okay, let's look at another example. Okay, here's another example. Go ahead, pause the video, and understand what they want us to do. All right, welcome back. So here again, they want us to find the vector equation of the line, which is just my R, my vector R, through the points, point A, which has a coordinate of 1, 0, -4, and point B has coordinates of -2, 1, and 1. All right, so let's try this. Now, in order for us to come out with the vector equation, all we need are two things. The position vector to any point that is on the line, plus a T is just some random value multiplied by a vector that is parallel, or in other words, a direction vector. Right now, they give us, they said that point A and point B, they are both on the line. So which means either one of them, I can use my point A, I could use this for that, or I can use my B for that. It doesn't matter which one we use, both are correct. So we actually get to choose, right? However, what about our direction vector? They didn't give us the direction vector, right? Because unlike the previous example gave us a vector that is parallel to the line, which is given here. And that is simply my vector B, my direction vector. But right now, I don't have that. All I know is this line passes through point A and B. Okay, so anyways, let me put down what I know. So my vector equation of the line R, vector R, is equal to, I'm gonna go with point B. Okay, I'm gonna go with point B, so that's my position vector of point B, plus T multiplied by the vector B. Now, the vector B, sometimes we call it a direction vector, right? So if this line we're talking about, the equation that we're trying to find for this line passes through A and B, then my vector AB will give me the direction of the line, correct? Because my line passes through point A and it also passes through point B. So if I have a vector coming from point A to point B, that will give me the direction. This will give me the direction of my line, right? A direction vector, right? This is a direction vector, which is also parallel to the line itself, correct? So I'm just going to do that. So my vector AB is my B in this case. Got it? Okay, so my vector AB is simply, so I'm going to say, so this is my vector OA, right? My vector AB would be from A to O plus O to B, which are just position vectors. So here I'm messing around with my position vectors a little bit. From A to O, I'll have -1, 0, and 4, plus my position vector of B is -2, 1, and 1. So my direction vector B, or my vector AB, is equal to -3, 1, and 5. And I'm just going to put that in. So this will be -3, 1, and 5. So there you go. That is my vector equation of the line passing through my point A and B. Okay, you might be asking, now, do I really have to, let me change a different color. For this part, vector AB, is it possible for me to use vector BA? That will give me some direction. That will give me a vector. And that vector would also be on the line, right? Just in the opposite direction of my vector AB. Yes, you're right. We can also do this. We can use this as well. We can use it. We can use it as my vector, as my direction vector for my vector equation, right? We can also use vector BA for my direction vector B. Okay, I think this is it for now, and maybe in the next video I'm going to show you guys another example that involves vector equation. Okay, see you, bye.